This video is the third video in the algebra set of videos. In particular, in this video, we're going to look at adding algebraic fractions. Adding algebraic fractions will also include subtracting algebraic fractions. Before we start looking at algebraic fractions, it's important that we go over how to add and subtract fractions. There's 5 steps that I use to add and subtract algebraic fractions that I think will work for any algebraic fraction you're given. Step 1, you find the common denominator. If you're unsure what it is, simply multiply the two denominators together. That will always work. Step 2, change the two denominators to the common denominator. Step 3, change the two numerators. Step 4, write the two fractions as one fraction. And step 5, simplify the numerators. These steps are best explained by going through examples. However, to begin, instead of looking at algebraic fractions, I'm just going to look at normal fractions which don't have an x in them. These can be found in example 3.1. 3.1 says, express each of the following as a single fraction, and in A, it has a third plus 1/6. So to begin here, in A, I'm going to have to find my common denominator. A common denominator is just a number that can be divided by all denominators to give a whole number. Usually, the common denominator can be found by multiplying the two denominators together if we have two fractions. However, sometimes the common denominator can be one of the denominators and we have to change the other fraction to this common denominator. In this particular one, the common denominator can be 6 because 6 divided by 3 will give us 2 and 6 divided by 6 will give us 1. So now we change the two denominators to the common denominator, which is 6. Next, we need to change the numerators. So we look at what we did in fraction 1. Well, we went from a denominator of 3 to a denominator of 6. We must have multiplied by 2. Because we've multiplied by 2 on the bottom, we must also multiply by 2 on the top. So it's going to become 2 times 1. On the right-hand side, or on the right fraction, it's gone from 6 to 6. In other words, it hasn't changed. So we must have multiplied by 1 or done nothing to it. This means it stays as 1/6. Now we write this all over one fraction, and in the numerators we get 2 times 1, which is 2, plus 1. That simplifies to give us 3 over 6, and that can break down to 1/2, or 1 over 2. In the second fraction, we have 3 over 4 plus 2 over 5. Again, we can get the common denominator by multiplying the two numbers in the denominator together. In this particular one, we have 4 times 5, which gives us 20. And that's the smallest number that both of the numbers will divide into evenly. Now, we change our denominators to have 20 on both denominators. Then we say to ourselves, okay, well, in 3/4, the denominator went from 4 to 20. So we must have multiplied by 5. So then we have to multiply the top by 5 too. In 2/5, the denominator went from 5 to 20, meaning we must have multiplied by 4. That means we have to multiply the top by 4 too. Then we write both over 20 and multiply the numerators out. Then we get 15 plus 8 over 20. 15 and 8 will give us 23 over 20. And that's the answer for part B. Part C and D are very similar. I'm not going to do them fully, but I'm just going to show you what you might do to begin. So, as normal, we have to get the common denominator. For C, the common denominator can be got by multiplying 3 by 4. Now, 3 by 4 will give us 12, so you change both the denominators on the fractions to 12. Write it all over 12 once you've changed the numerators to match what happened to the denominators. And then take away the fractions. The same can be said for D. The common denominator can be got by multiplying 7 by 4, giving a common denominator of 28. Then change the two fractions to having a denominator of 28 and add the fractions once you have changed the two numerators to match what you did to the denominators.
Looking at example 3.2 now, it says express each of the following as a single fraction. And we can see here that we have algebra introduced. We have variables, and in particular, all of these examples have x as the variable. However, there is absolutely no difference in how we do this type of question to the question we did before. So what we'll do is we'll start with a, and a here is x over 2 plus x over 3. Again, I'm going to get my common denominator, which I'm going to put as CD. My common denominator is 2 times 3. 2 times 3 will give us 6, so 6 is our new denominator. I'm going to write both fractions over 6 and pop the plus sign between them. Now what I do is I look at the first fraction on the left-hand side and I say, what did I do to the 2 to make it 6? Well, I multiplied the 2 by 3 to make it 6. That means I must multiply the top part, or the numerator, by 3 too. So we'll get 3 times x. On the other side, we have 3, and that 3 became 6. We would have had to multiply the 3 by 2 to make it 6, so we must multiply the top by 2 too. Now it's become 2 times x. As we have a similar denominator, we can write it all over one denominator and add the top terms. Now 3 times x will just become 3x, and 2 times x will become 2x. So we'll have 3x plus 2x over 6, which simplifies when we add the like terms on top to 3 plus 2, which is 5x over 6. Part B is very similar. We have 3x over 4 plus 3x over 2. To begin, like the last one, I get my common denominator. I hope you can spot here that both of these numbers could go into 4. So instead of multiplying the denominators here, I'm going to change both to 4. Now the first fraction is already over 4, so we can leave that the way it is. But the new fraction is going to be over 4, and we can change the second fraction to the new fraction by seeing what we did to make it 4. So we would have had to multiply the 2 by 2 to make it 4. That means on the top we need to multiply the 3x by 2 too. Now that both fractions are over 4, we can write it as one fraction. This then will become 3x plus 2 times 3x, and 2 times 3x is 6x. 3x and 6x will give us 9x, and that's over 4. Example C is very similar. On C we have 5x over 3 minus x over 2. To begin, I can get my common denominator, and my common denominator is got by multiplying the two denominators. The two denominators are 3 and 2, so 3 by 2 will give us 6. Now we have our new denominator of 6. Now we must change the fractions so that they match with the new denominators. So we first of all on the left hand side had the denominator of 3. It's now gone to 6, so we must have multiplied by 2, meaning we'll have to multiply the top of this fraction by 2 as well. So that becomes 2 times 5x. On the right hand side we had 2 and now it's 6, so that has to have been multiplied by 3. As we've multiplied the bottom by 3, we also have to multiply the top by 3, so this becomes 3 times x. As they're both the same denominator, we can write it all over one denominator, and we get 2 times 5x, which is 10x, minus 3x. Adding the denominators together, we have 10x minus 3x, which will give us 7x over 6. Finally, the last one is slightly different, but we do it in the exact same way. So we have 2x plus 3 all over 3 minus x over 4. What we have here is two denominators that are different, so we need to get our common denominator. Our common denominator in this case is 12, as 3 by 4 gives us 12. Rewriting both denominators as 12, we can then change the numerators as a result. On the left hand side, we had the denominator of 3 and it changed to 12, so it must have been multiplied by 4, meaning we also need to multiply the top by 4. We'll get 4 times 2x plus 3, remembering that the entire numerator has to be multiplied by 4. On the right hand side, we had 4 as our denominator, and now it's 12, meaning we would have had to multiply by 3, meaning we have to multiply by 3 for the numerator too. As they're both the same denominator now, we can write it all over one denominator. And we can also multiply out the brackets. Here we have 4 by 2x and also 4 by 3, meaning we'll get 4 by 2, which is 8x, and 4 by 3, which is 12. We'll also get 3 times x, which is minus 3x then. Adding the like terms finally, we have 8x minus 3x, which will give us 5x plus 12 over 12. Just to note, you could also write this as 5x over 12 plus 12 over 12, which would break down to 5x over 12 plus 1. However, if it asked you to write as a single fraction, you would just leave it as 5x plus 12 over 12. Example 3.3 looks a little bit different than some of the examples that we've gone through already. However, we complete it in the exact same way. To begin, we'll write down the fraction. So in A, we have 2 over x plus 5 minus 3 over x. Here, we start by getting our common denominator. Our common denominator is gotten by multiplying our two denominators. When we multiply x plus 5 by x plus 5, we end up with x plus 5. In this, we don't need to multiply out the brackets. And in fact, it's better not to multiply out the brackets, because in later questions where you're factorising, you'll see that when you leave the brackets like this, it can simplify at the end. Therefore, we write our new denominators as x plus 5. As usual, we check what's happened to each fraction. So on the fraction on the left, the denominator was x plus 5, and it's now x plus 5. So we must have multiplied the denominator by x. As we've multiplied the denominator by x, we must also multiply the numerator by x. On the right-hand side, it was x, and now it's x plus 5. We multiplied the denominator by x plus 5, so we must multiply the numerator by x plus 5 too. It's important that you include your brackets here, as you need to multiply the 3 by x and by plus 5. As we now have the same denominator, we can write it all over one denominator. X by 2 will give us 2x, and then we have x by 3 and 5 by 3. That will give us 3x plus 15. You must be careful of the minus sign here to include it on the next line, because that's really important. What we'll get then on the next line is we'll get 2x, and then the minus sign goes with the remaining terms. We get minus 3 minus 15 all over x plus 5. Simplifying this at the end then, we get 2x minus 3x, which is minus x, minus 15, and that's all over x plus 5. Example B is similar to example A. The only difference is the two denominators have a variable plus a constant. We have 2 over x plus 2 minus 3 over x plus 4. The common denominator for both of these, we have x plus 2 multiplied by x plus 4. That will give us x plus 2, x plus 4. Now that we have our common denominator, we change both fractions to have the common denominator. Next, we look at the fraction, firstly the one on the left, and the denominator was x plus 2, and now is x plus 2, x plus 4. So the denominator was multiplied by x plus 4. As the denominator was multiplied by x plus 4, the numerator will have to be multiplied by x plus 4 too. Similarly, when we look at the fraction on the right-hand side, the denominator was x plus 4 and is now x plus 2, x plus 4. We must multiply the numerator by x plus 2. When we do that, we'll get x plus 2 times 3. Again, there's a minus sign here, which we'll have to keep into account when we're doing the next step. The next step involves putting it all over the same denominator, which again is x plus 2, x plus 4. We can multiply out the terms. We get 2 times 4, 2 times x, and we'll get 3 times 2, 3 times x. 2 times x will give us 2x, and 2 times 4 will give us 8. We have the minus sign, which we have to keep into account. So we open up a big bracket, we'll get 3 times x, which is 3x, and 3 times 2, which is 6. Simplifying that then, by multiplying the minus in, we get 2x plus 8 minus 3x minus 6. All of that then is over x plus 2, x plus 4. Adding the like terms in the numerator then, we get 2x minus 3x, which is minus x, and 8 minus 6, which is plus 2. All of that then is over x plus 2, x plus 4. That's example 3.3a and b. C and D are very similar. The only thing you have to do in C and D is have different denominators, but they're got in the exact same way. For example, in C, the denominator is got by multiplying 2x minus 1 by 2x minus 3, which gives us 2x minus 1, 2x minus 3. In D, the common denominator is 3x minus 1, 2x plus 3. So when it has variables in the denominators and you're trying to find the common denominator, you just multiply the two denominators by each other and leave it in the unmultiplied out form. Don't simplify it. And again, the reason why I say this is because later on, when you factorize and you're left with a fraction, when it's not multiplied out, sometimes parts of the denominator and numerator will be able to cancel after you've factorized. This brings the video of algebraic fractions to an end.